So friends, we are trying to solve this problem wherein it is given that a boy is standing at the top of a tower and uh, and it drops a stone. So now let's assume that this is the tower here. There's a tower here on the ground and he drops the stone from here. So when he drops the stone, obviously this will fall down. And why it is dropping down? Because of the acceleration due to gravity, which is g here. Okay, and g is given to be 10 meters per second square here. So when it drops the ball or drops the stone, this will drop with this acceleration due to gravity. The height of the tower is given to us as 45 meters. Okay, fine. So this is stone which is being dropped from the height of 45 meters. And what we need to find here, it is given here that we need to find the velocity with which it hits the ground, right? Yeah. So let's understand. So there are three fundamental formula which all of you must be knowing, which is V is equal to U plus ET. V is the final velocity of a body, U is the initial velocity, A is the acceleration by which it is moving forward, and T is the time elapsed. The second formula you must be knowing as well is V square is equal to U square plus 2AS. So here what is A is acceleration due to gravity, S is the distance traversed by the body. The third formula we know is S is equal to UT plus half AT square. So these three are the most important formula in case of motion which you need to know. So now coming back to this problem, what is given to us is that the distance which is being traversed by the body from the top, S is equal to 45 meters, right? And it is being dropped from the top, which is mentioned here, right? It is being dropped here. It is not that he's throwing with an initial velocity, he's just dropping the stone. He's not making any effort to throw the ball. It means U is equal to initial velocity is equal to 0. Yeah. So S is equal to 45 meters and the G is also given here. It is 10 meters per second square. So now what do we need to find? We need to find the value of V, which is the final velocity with which the stone touches the ground. So it is very straightforward here. So we can straight away apply this formula here, which is V square is equal to U square plus 2AS, right? So let's apply the formula here. We know V square is equal to U square plus 2AS. Okay. U is equal to 0. So what we'll get here, V square is equal to U. U, as I said here, that U is equal to 0, right? So V square is equal to 0 square plus 2 into the acceleration by which it is dropping, which is equal to G, and the height by which is dropping, right, which we can take as the height of the building. So this is equal to 0 plus 2 into 10. G is equal to 10. Height of the building is equal to 45. So this is equal to 900. So what does it mean? V square is equal to 900 means V is equal to root of 900, which is equal to, it means V is equal to 30. It means the velocity at which the body or the stone touches the ground, it is 30 meters per second, which is A. Let's go to the next problem now. It is given that a particle moves the distance x in time t according to the equation this, the acceleration of the particle is proportional to. So here we need to identify that what is the relation between the acceleration and the velocity or the distance, right? To identify that which is the right choice here. before we go there, right, so I think we need to give some basic insight into how is the velocity being computed from a graph. So imagine that this is the distance time graph, right? So if the distance time of uniform like this is very simple, that everyone knows. Imagine that this is the distance given and this is the time. So if this is the case, this is very simple, right? So we know that the velocity is uniform here. That is the relation between x and t is uniform. So this is uniform. So this is very simple. Now imagine, so this is, I'm just taking a scenario number A. Okay. Imagine another scenario wherein the graph is something like this. Yeah. So in such cases, what we do is that how do you find the velocity here at any point in time? So what we'll do is that we will take 2 points close to each other, right? If you take 2 points close to each other, then we will be able to find the velocity at that instant, right? At that very small instant in time. So here, let's take these two instances here. So imagine these two are there. So what is the difference between the distance here? The dx. And what is the difference between the time here, which is equal to dt? Yeah. So what is the velocity at this point in time? At this point, the velocity is equal to dx by dt. So this is the velocity at this point in time. And what is the acceleration at that point in time? Acceleration is equal to one further differentiation of this, which is d2x by dt2. Okay, so this we need to remember. Yeah, coming back to the problem here, so what is given here is that x is equal to t plus 7 minus 1. So just to let you know, what is t plus 7 minus 1 is nothing but 1 by t plus 7, right? So now if x is equal to t plus 1, t plus 7 minus 1, yeah, so what will be the first differentiation of dx by dt, which is equal to dx by dt is equal to minus 7 into t plus 7 minus 2. Okay, this is nothing but the velocity, as we mentioned at the bottom, right? The velocity is nothing but the dx by dt. So now we need to find the acceleration also, right? So now what is the acceleration here? Acceleration is equal to d2x by dt2. Okay, so which is equal to that. Again we take another differentiation or further differentiation of dx by dt. So we basically need to differentiate this once again, right? So if we differentiate this once again, we'll get minus 1 into minus 2 is equal to plus 2, and this t plus 7 minus 3. And we don't have any coefficient for t here, so we don't have to do anything. So this is into 1. Okay, so this becomes 2 into t plus 7 to the power minus 3. So this becomes the acceleration. Now let's understand that what is the ratio between the acceleration and the velocity. So acceleration divided by velocity is equal to 2t plus 7 minus 3 divided by velocity. So velocity is what? We saw here velocity is given here, right? We saw velocity is mentioned here, correct? So velocity is this, so it is minus 1 t plus minus 2. So what will this turn out to be? This 2 by minus 1 is minus 2, and t plus 7 minus 3 and t plus 7 minus 2. So t plus 7 minus 3 plus t plus 7 minus 3 plus 2 is equal to minus 1. Okay, so it means acceleration by velocity is equal to minus 2 t plus 7 minus 1. Now one important thing here is that what is t plus 7 minus 1? Now if you look at this one, velocity is equal to t plus 7 minus 2, right? So let's for a while, let's forget this coefficient here, because we only need to find out the proportionality. So if proportionality, we can just ignore the constants. We are not worried about the constants here, okay? So here, so velocity, we can say velocity is equal to k and t plus 7, sorry. So yeah, so velocity is equal to k t plus 7 minus 1. So here the t plus 7 minus 1 is given here. So it means t plus 7 t plus 7 minus 1. Now this is given to be, sorry, this is minus 2 actually. Sorry. So this is t plus 7 minus 2. So t plus 7 minus 2 is proportional to the velocity. Okay. So t plus 7 minus 1 is proportional to root of velocity. It means this is velocity to the power half. Now coming back to this one, this one. Okay. So coming back to this one. Okay. So velocity, so acceleration by velocity is equal to, this is proportional to velocity half, actually half, velocity half, this is proportional to velocity half. It means acceleration is proportional to velocity 3 by 2. Okay, so this is the answer. If you look at this, first one is the answer, very first one. Going to the next problem. A particle moves in a straight line. So imagine that a particle is moving in a straight line like this. Okay, with a constant acceleration. So acceleration is constant. Acceleration is a, it is constant, it is 4 meters per second square. It is given here. Sorry, extremely sorry, it is not given here. Okay, acceleration is not given to us, but acceleration is given to be constant. So it means acceleration is not changing. The initial velocity here is 20 meters per second, and the final velocity here is 30 meters per second. And what is the distance between them? The distance between them is given to be 125 meters. Okay. So it traverses this distance 125 meters in a time span of t seconds, and we need to find the value of t. So we all know those three formulas which we discussed earlier, which we mentioned here, these three formulas here. So we'll go and relate to those formulas once again now. So here v square is equal to u square plus 2as. Okay. Here we need to, what we have been given here is that we have been given the value of s, we have been given the value of initial velocity, and we have been given the value of final velocity, right? So 2as is equal to v square minus u square, means a is equal to v square minus u square, yeah, upon 2s. So v square is 30 square, u square is 20 square. On initial, this is initial velocity, this is the final velocity. Divided by 2 into s. S is 125 meters. So this becomes 900 minus 400 is 500. 500 divided by divided by 250. This is equal to 2. It implies that the value of A is equal to 2. Now, having known this, now we can apply this to this formula, right, in order to get T. Okay, so coming back to this, we know V is equal to U plus AT, right? So what is T? T is equal to V minus U divided by A. This is equal to, so what is V here? V is given to be 30. 30 minus 20 divided by A is equal to 2. So this is equal to 10 by 2. This is equal to 5. It means the time taken is equal to 5 seconds. So if we look at the answers, we have this 5 seconds here. Okay, let's move to the next problem now. So here it's given that the distance traveled by a particle starting from rest and moving with an acceleration of 4 meters per second square. How much does it travel in the 4th second? Okay, so now imagine a particle is moving from here. A particle is moving from here to here. Okay, so this is A and this is B. So this is the time taken is 4 seconds to travel from A to B. Okay, now let's break it second wise. First second, so this is the first second, this is the second second, this is the third second, and this is the fourth second. Okay, so in 4 seconds this body moves from A to B, and what is the acceleration? Acceleration is given to be 4 meters per second square. Okay, so we need to know how much is it traveling in the 4th second. So how do you do that? If we somehow calculate this total distance from here to here, okay, and then minus the distance traveled in the first 3 seconds, then we will be able to get this distance which is traveled in the 4th second, right? We're pretty straightforward here. So how much is the distance traveled in 4 seconds? So we need to first find this one, right? We need to first find this distance and then find this distance and then subtract to get this distance. Yeah, so distance in 4 seconds, okay, S is equal to UT plus half AT square. Now initial velocity, it starts from rest. It is given in the problem. It is starting from rest. Okay, so S is equal to U is equal to 0. So it means S is equal to half AT square. Okay, so how much is S then? S is equal to half into A is 4 is given in the problem, and T 4 seconds, right? 4 square. This is equal to 2. So S is equal to 32 meters. It means this distance in 4 seconds is 32 meters, right? In 4 seconds it travels from this place to this place in this is 32 meters. Yeah, the second thing is that we need to now identify that how much does it travel in 3 seconds, right? So similarly we will apply the same formula here. So S is equal to S in 3 seconds is equal to half into 4 into 3 square. Okay, this is equal to, this gets cut here. So 2 into 9 is equal to 18 meters. Okay, this is the distance traveled in 3 seconds, which is 18 meter. It means then what is the distance? What is the distance traveled in the 4th second? So this is equal to 32 meters minus 18 meters. This is equal to 14 meters. So this is the answer. This is a distance in 4th second. Okay. So if you look at the answers given to us, so this is the answer. Okay, let's move to the next problem. Two bodies of one of mass 5 kg, other of mass 9 kg are dropped from heights of 10 meters and 40 meters. What a ratio of time taken by them to reach the ground, right? So imagine that this is the ground here. Okay, one body is dropped from here, it's 10 meters. Other body is dropped from here. Imagine that this is 40 meters height, and this is 10 meters height. Okay, so we need to know the ratio of the time taken by them to reach the ground, right? So let's first put the formula. We know that S is equal to ut plus half at square. So they are all starting from, they are being dropped, right? So they are being dropped, so it means the u is equal to 0. It means S is equal to half into, now it is being dropped to the from the top, right? So it means there is acceleration of gravity here, g into t square. So how much is t square? Is equal to 2s by g. So the time given is 2s, time square is equal to 2s by g. So let's look at for the two bodies. There are two bodies here, right? One of mass 5 kg, other of mass 9 kg. Okay, so the time taken by the body of 5 kg is equal to 2s t square 2s by g. Okay, so t of 5 is equal to s by g square root, right? Similarly, t10 square, the same logic, is equal to 2s by g is equal to, okay, so in this case, so s is given to 10 meters, right? So this will be 2 into 10 by g. Okay, in this case this will be 2 into 40 by g. This is for the time taken, this time taken for the body which is being dropped from a height of 10 meters, right? Sorry, this is the 40 meters height and this is the 10 meters height. This is the body of 5 kg, this is the body of 9 kg, right? So yeah, this is the body of 9 kg and this is the body of 5 kg. So now we need to find the ratio, right? So ratio is nothing but t of 5 divided by t of 9, right? So this is equal to 2 into 10 by g divided by 2 into 40 by g. Okay, so this is 1 by 4. This is root of 1 by 4, means t of 5 by t of 9 is equal to half. So the timing, the ratio of the timing is nothing but half. So we have half in the answer here. So this is the answer, right? Let's go to the next one, right? A particle moves along a straight line, say OX. Imagine this particle is moving a straight line OX. This is O, this is X. Okay, the time, the distance x of the particle from O, so this is the x, this is the distance given, the distance of the particle, and this is given by this equation here. Okay, it says how long will the particle travel before coming to rest. So x is equal to 60 plus 4080 minus p cube. Okay, so how do you find this out? Like, let's understand this, right? a body is traveling. So imagine that. So let's take a distance time graph, right? Distance time graph here. So let's say hypothetically, let's say some one graph is there, right? Okay, the distance is given by this, right? So in this case, or rather, let me change the graph. The graph doesn't seem to be proper. Okay, so imagine. Okay, so this is the distance being traveled by the body in time t. Okay, so this distance is not uniform, right? It is a zigzag. There is a zigzag here. I mean the velocity is also not uniform, right? So now what will happen? So let's understand that why when the particle comes to rest, what will happen at that point? So when the particle is coming to rest, it means at that time the velocity of the particle will be zero, right? The velocity of the particle will be zero. Now, if the velocity of particle is zero, what does it mean? I think that dx by dt, this is equal to zero, right? This is the similarly. Imagine that it was given that acceleration is zero. Okay, then what will happen is that the d2x by dt2 would have been zero, correct? So now, not digressing, so let's not focus on this for now. Let's focus on this one. So what is dx by dt here? If x is this, what will be dx by dt? Dx by dt is equal to, so this is a constant, differentiating this will become 0. Dx by dt of this is 48 minus t cube, this thing is 3t square. Okay, so it means that this is equal to 0. It means 3t square minus 48 is equal to 0. 3t square is equal to 48. Mean t square is equal to 48 by 3 is 16. Okay, it means t is equal to 4, right? So it means at time t is equal to 4, at some point in time, after some time, so imagine 1, 2, 3, 4, what will happen is that the velocity will become 0. So what is, from this signal, what does it mean is that at this point in time, somewhere here, the graph will become horizontal here. Okay, then only dx by dt is equal to 0. So here, if you look at this, this is the value of t. Okay, so we will conclude with these 6 problems for now, and we'll have another video in which we will solve the rest 6 problems. Thank you.